Positive pressure requirements for Class 1 Division 2 areas are essential for safety. The National Electrical Code, or NEC, Section 501.15b requires a positive pressure relative to the unoccupied areas for Class 1 Division 2 areas. NEC Section 505.9b3 gives guidance on the need for a slight positive pressure, but does not specify a precise value. The NFPA 30 standard does not provide specific requirements for positive pressure in Class 1 Division 2 areas. However, it advises the use of a positive pressure air supply or ventilation system to stop the buildup of hazardous vapors or gases. Typically, a minimum positive pressure of 0.1 inches water column is considered adequate for Class 1 Division 2 areas. This pressure level aids in preventing potentially hazardous fumes from entering the office area. To measure the positive pressure, you can use a manometer or a digital pressure gauge. Firstly, place the sensing end of the manometer or gauge in the office area. Secondly, connect the reference end of the manometer or gauge to a location outside the Class 1 Division 2 area. Thirdly, read the positive pressure value on the gauge. The positive pressure system should be designed by a qualified professional. A system should be tested and maintained regularly to ensure proper operation. If the positive pressure is lost or fails to meet the specified requirement, the office area should be evacuated, and hazardous material should be removed or controlled. Maintaining positive pressure in Class 1 Division 2 environments is crucial for safety. It involves understanding relevant codes, measuring pressure accurately, and ensuring regular system maintenance. The NEC provides guidelines emphasizing the necessity of positive pressure to protect unoccupied areas from hazardous substances. While NFPA 30 doesn't specify exact pressure values, it advocates for ventilation systems to prevent vapor accumulation. Industry best practices often recommend a minimum of 0.1 inches water column to effectively keep hazardous fumes out. Measuring positive pressure requires tools like manometers or digital pressure gauges. The process involves correctly positioning the sensing and reference ends of the measuring device and interpreting the readings. The design of these systems needs expertise to ensure efficacy and compliance with regulations. Regular testing and maintenance are vital for the consistent performance of the positive pressure system. Loss of pressure or failure to meet required levels necessitates immediate action, including evacuation and hazard control. By adhering to these guidelines, you can create a safer working environment in Class 1 Division 2 classified locations. Positive pressure systems are a key component in ensuring safety within hazardous locations, specifically those classified as Class 1 Division 2. The goal is to maintain a higher air pressure inside a protected room or area relative to the surrounding potentially hazardous environment. This pressure difference prevents the ingress of flammable gases, vapors, or liquids, reducing the risk of explosions or fires. Several codes and standards provide guidance on the implementation and maintenance of positive pressure systems in these environments. The National Electrical Code, or NEC, is a widely adopted standard for electrical safety. Within the NEC, specific sections address hazardous locations, including Class 1 Division 2 areas. These sections outline the requirements for electrical equipment and wiring methods to minimize the risk of ignition. Although the NEC mandates positive pressure, it doesn't always specify a precise pressure value. Instead, it emphasizes the need for a pressure sufficient to prevent the entry of hazardous substances. NFPA 30, the Flammable and Combustible Liquids Code, offers guidance on the storage, handling, and use of flammable liquids. While it doesn't explicitly define positive pressure requirements for Class 1 Division 2 areas, it recommends using ventilation systems to prevent the accumulation of hazardous vapors. These ventilation systems often incorporate positive pressure as a means of achieving this goal. Industry best practices often call for a minimum positive pressure of 0.1 inches of water column, or IC. This value is considered a practical threshold for preventing the entry of hazardous substances. However, the specific pressure required may vary depending on factors such as the size of the room, the potential sources of hazardous materials, and the effectiveness of the ventilation system. To accurately measure positive pressure, you can use a manometer or a digital pressure gauge. A manometer is a simple device that measures pressure by comparing the height of a liquid column in two interconnected tubes. A digital pressure gauge provides a direct digital readout of the pressure. The measurement process involves placing the sensing end of the instrument inside the room or area where positive pressure is to be maintained and the reference end outside in the potentially hazardous environment. The instrument then measures the pressure difference between the two locations. Regular testing and maintenance are essential to ensure the ongoing effectiveness of a positive pressure system. This includes verifying the pressure level, inspecting the ventilation system for leaks or obstructions, and calibrating the pressure measuring instruments. Any deviations from the required pressure or system malfunction should be promptly addressed. It's also important to consider the potential consequences of a positive pressure system failure. If the pressure drops below the required level, hazardous substances may enter the protected area. In such cases, appropriate safety measures should be taken, such as evacuating the area and shutting down equipment that could ignite flammable materials. When designing and implementing a positive pressure system for a Class 1 Division 2 area, it's advisable to consult with qualified professionals who have experience in hazardous location safety. They can help assess the specific risks, select appropriate equipment, and ensure that the system complies with all applicable codes and standards. Remember that maintaining positive pressure is just one aspect of overall safety in hazardous locations. Other measures, such as using explosion-proof equipment and implementing proper grounding techniques, are also crucial for minimizing the risk of explosions and fires. In summary, positive pressure is a critical safety measure for Class 1 Division 2 areas. It involves maintaining a higher air pressure inside a protected area to prevent the entry of hazardous substances. The NEC, NFPA 30, and industry best practices provide guidance on implementing and maintaining these systems. Regular testing, maintenance, and consultation with qualified professionals are essential to ensure their ongoing effectiveness. Understanding the principles of positive pressure and adhering to relevant codes and standards are crucial for creating a safe working environment in hazardous locations. Ensuring a safe working environment in Class 1 Division 2 hazardous locations requires a comprehensive understanding of positive pressure systems and their role in preventing the accumulation of hazardous materials. These systems are designed to create a pressure differential between the protected area and the surrounding hazardous environment, effectively preventing the ingress of flammable gases, vapors, or liquids. Positive pressure is typically achieved through a combination of ventilation and pressurization equipment. The ventilation system introduces clean air into the protected area, while the pressurization equipment maintains the desired pressure differential. The design and implementation of a positive pressure system must consider several factors, including the size and configuration of the protected area, the potential sources of hazardous materials, and the environmental conditions. The system must be capable of delivering sufficient airflow and pressure to effectively prevent the ingress of hazardous materials under all operating conditions. To ensure the effectiveness of a positive pressure system, it's essential to establish a regular monitoring and maintenance program. This program should include periodic inspections of the ventilation and pressurization equipment, as well as regular testing of the pressure differential. Any deviations from the required pressure or system malfunction should be promptly addressed to prevent the accumulation of hazardous materials. The selection of appropriate equipment for a positive pressure system is critical to its performance and reliability. All equipment used in hazardous locations must be properly rated and certified for use in the specific class and division. This includes ventilation fans, pressurization units, sensors, and control systems. In addition to selecting appropriate equipment, it's also important to ensure that the system is properly installed and maintained. This includes following manufacturers' recommendations for installation, maintenance, and calibration. Regular training should be provided to personnel who are responsible for operating and maintaining the positive pressure system. The training should cover the principles of positive pressure, the operation of the equipment, and the procedures for responding to system malfunctions. Effective communication is also essential for ensuring the safety of personnel in hazardous locations. This includes clearly communicating the location of hazardous areas, the potential hazards, and the procedures for responding to emergencies. Warning signs should be posted in prominent locations to alert personnel to the presence of hazardous materials. In addition to positive pressure systems, other safety measures should be implemented to minimize the risk of explosions or fires in Class 1 Division 2 hazardous locations. These measures include the use of explosion-proof equipment, proper grounding and bonding, and the elimination of ignition sources. Explosion-proof equipment is designed to contain any explosion that may occur within the equipment, preventing it from propagating to the surrounding environment. Proper grounding and bonding help to prevent the accumulation of static electricity, which can be a source of ignition. The elimination of ignition sources includes controlling smoking, open flames, and other potential sources of ignition. By implementing a combination of positive pressure systems and other safety measures, it's possible to create a safe working environment in Class 1 Division 2 hazardous locations. This requires a commitment to safety from all personnel, as well as a thorough understanding of the potential hazards and the procedures for mitigating them. Regular audits and inspections should be conducted to ensure that all safety measures are in place and are being followed. The results of these audits and inspections should be used to identify areas for improvement and to implement corrective actions. In conclusion, maintaining a safe working environment in Class 1 Division 2 hazardous locations requires a comprehensive approach that includes positive pressure systems, explosion-proof equipment, proper grounding and bonding, and the elimination of ignition sources. A commitment to safety from all personnel is essential, as well as a thorough understanding of the potential hazards and the procedures for mitigating them. Regular audits and inspections should be conducted to ensure that all safety measures are in place and are being followed.